Understanding the motion of objects under gravity can be a challenging affair. It's like trying to decode why an apple falls straight down from a tree instead of floating away. Yet, it's a fundamental concept that governs how everything moves in our universe, from a basketball arcing towards the hoop to the flight of a space rocket. Now, imagine a scene where a soccer player kicks a ball. It soars into the sky, reaches a peak, and then descends back to the ground. What's happening here is a display of two types of motion: vertical motion under the pull of gravity and horizontal motion from the initial kick. This is what we call projectile motion. To break this down, consider the initial kick as the force that sets the ball into motion. This force imparts an initial velocity to the ball, which we'll denote as v₀. The direction of this initial velocity is important as it determines the path the ball will take. The ball then starts moving upwards against the force of gravity. This is where the equation of motion under gravity comes into play. The ball's position at any given time t can be calculated using the equation x equals x0 plus v₀ times t plus half g times t squared. Here, x is the position of the ball, x0 is the initial position, v₀ is the initial velocity, g is the acceleration due to gravity, and t is time. Meanwhile, the velocity of the ball is constantly changing due to gravity's pull. It can be calculated using v equals v₀ plus g times t, where v is the velocity at time t, v₀ is the initial velocity, and g is the acceleration due to gravity. Finally, the acceleration of the ball is constant and equal to g, the acceleration due to gravity. Now, back to our soccer ball. As it begins to descend, it follows a parabolic trajectory, a characteristic of projectile motion. Here, the horizontal and vertical motions of the ball can be described separately. The horizontal velocity vex remains consistent at v₀x. The initial horizontal velocity, the vertical velocity vy, however, changes over time, calculated as v₀y plus g times t, where v₀y is the initial vertical velocity. The range r of the ball, or the horizontal distance it covers, can be calculated as v₀x times 2. The total time the ball spends in the air, known as the time of flight t, can be determined as 2 times v₀y divided by g. Understanding these concepts and equations not only helps us comprehend the world around us better, but also has practical applications. Engineers use these principles to design vehicles. Architects use them to build safer structures, and athletes use them to improve their performance. So, the next time you see a soccer player aiming for a goal, remember, it's not just about power and precision. It's also about understanding the science behind the kick.